Hey, good afternoon, everyone. Nice to meet you again. Welcome to day two in room one. My name is Lutfi Zuhrina. I'll be your moderator again for the first session in this room today. This is a special room because we will discuss geosciences from start to the end. So, if you're a student, academics, or professional in this field, this is the best place for you. We have Izzul Qudsi here as our speaker. Izzul Qudsi is a geoscientist at Horizon Perdana. The title of his talk is Python for Geoscientists, Machine Learning, and Beyond. He will give a brief presentation about the use of Python in the geoscientific subject. He will mention some of the actual practices in the industries and researchers. He would like to show the audience the ability of Python to help their daily tasks, for example, to overcome the limitation of their currently owned software, to perform other possible operations for a specific analysis, or even perform an analysis that they haven't had the software yet. So if you have any question, you can ask through Hopin. Isil will answer your question in Q&A session. So let's give a big virtual applause to Isil Qudsi. Isil, the stage is yours.
Okay, good afternoon, everyone. First of all, I would like to thank Mr. Lutfi for the kind introduction. Okay, today I would like to share about how Python could help us, the geoscientists, in dealing with our daily tasks. I will share a few of my experiences and some of insight from the society I know out there. But again, I would like to thank the PyCon committee for the opportunity. Finally, we have several geoscientific topics this year. I was in Surabaya in last year, PyCon 2019, and that's simply awesome. Today we have three geoscientists in the same room. So let's start with me introducing myself. My name is Izzul Qudsi. I'm a geologist. Actually, I never had any computer or IT education background. I have my bachelor on from University of Pajajaran and my master in the same major, geoscience, from University of Twente. But it's not a problem for me to learn this programming language. Then now I'm working as technical support of Horizon Perdana, not only to provide several technical assistance for our software like seismic inversion, Dream Completion Manager, and any other software that we provide. I'm also part of the database management system developer because of my ability code in Python. So what Python have done to me during my MSc, the research method that I want to use is not supported by the software provided by my research group. So I decide to use Python library to get it done. I will go through this experience later on this talk. And as I mentioned earlier, because of my ability to write some codes in Python, I am included to the so-called IT department, the data management developer team. Then, since I have very limited geoscientific project in my company, I decide to play around with open source data to perform several analysis with Python to keep up my geoscientific knowledge updated. I will also share this experience in this talk as well. So this afternoon, I divide this talk into three different parts. First is about how this Python become popular to our geoscientist society. Then I will move on. Uh, what is Python for geoscientists? And finally, I will try to show you several examples that has been done out there. In the past few years, the interest of machine learning discussion grows significantly around the geoscientist society. In fact, this technique always been there for years, with less of them realizing, like seismic inversion, any kind of modeling. We already use this machine learning technique. Python has been used by many geoscientific software developers such as Schlumberger, Halliburton, OpenDetect, as the plugin for the implementation of machine learning module on their product in the last few years. Here in Indonesia, this topic has been very popular recently, especially during the COVID-19 lockdown period. Many of them are starting to learn Python to catch up with the hype of machine learning discussion. So machine learning is one of the branch of data science, the most trending topic this day. While data science has very broad scope, including any kind of operation to a data like data cleansing, preparation, and any other kind of operation, while machine learning is practically only using the algorithm to use the data, to learn from it, and predict the future trend of the data set. Uh, let's move on to the machine learning in and the implementation of machine learning in geoscientific matters. Machine learning requires a good amount of data to produce a better result. As we know, we have hyperspectral imagery or seismic cube, that kind of huge geoscientific data which are very suitable for machine learning to be applied. Actually, it's also applicable to other kind of data set like PLAS or geochemical data or any laboratory data. But of course, it will reduce the quality of the result because the quality of the data also have a huge impact on the result of the machine learning model. Process like identifying salt dome or fault in seismic cube or mineral mapping using hyperspectral imagery are the place where machine learning could help to save our time as a scientist. Instead of interpreting it manually, we can like asking the machine to do this interpretation for us. Basically, any kind of modern modeling technique are machine learning method. Like we ask the computer to run a Kriging interpolation, making a voxel three dimension, or any kind of inversion I also mentioned earlier. That's basically is a machine learning tool. So Python offers various solutions for us. These are several problems that Python could solve. First, you can manage your data in Python, like data cleansing, processing, or any other operation you need to your data, so you can manage your data better. Then you can also perform any quantitative data or data-driven analysis more efficiently using the machine learning technique. And if you are a student and do not have access to the expensive software such as Petrel, Geolog, and any other kind of technical software that will not stop your work, you can still publish a paper or maybe doing some research by coding it by yourself. I will show you one of the simple algorithm, simple code that you can use in the future, maybe like doing petrophysical analysis using Python. This will be in my talk this afternoon. And also, if you came up with a new method developed by your own group, like if you are a PhD or researcher or maybe lecturer or that usually came up with new method and no software yet that could handle your method, again, you can code it by yourself instead of asking for the software developer or buying new software this and that and mix and match. You can code it by yourself. I did it by myself actually. And you can also reduce the time consumed by the repetitive manual tasks that could also uh, produce a human errors that you can avoid by asking machine to do this. Like this case, we use Python. And of course, there are still many other problems that Python might able to solve out there. I cannot mention them all, but I'm sure maybe you already know that. Oh, I have this problem that we can solve it using uh, use Python, something like that. So if you are just IT and want to learn Python for machine learning purpose, it's fine. But this guy has more capabilities more than just machine learning tool. I already mentioned it several machine learning implementation like process classification, fault identification, but there are also many non-machine learning process we can do in Python, such as petrophysics, DM visualization, well log and sequence visualization, and if you are good enough in Python, you maybe want to create your own software that you came up with new idea, new method, you publish the paper, so you can like build your own software, so you can help the other people to follow your paper by using your own software. So Python is a tool. Yes, it is. Python is not more than just a tool for is not more than just a tool for us. Python could be a very convenient tool for geoscientists with any level of proficiency. So anyone can write Python code. Trust me. I will show you later, and you might agree with me by the end of this presentation. I think I could fairly categorize this tool based on the user need. Like it could be a casual tool because you just simply apply the libraries to your dataset and see how it goes. Like oh, I found a machine learning libraries for my log data and apply that to your data and see how is the result. If you are happy, you can use it. If you're not, maybe you can improvise a bit, but then you move on to the next level of the tools, like a problem solving tool. Like myself, when I did my research in my master, I need to mix and match several libraries to solve my own unique problem, and maybe you can be this one too. And I know many of my friends having this kind of problem, and I suggest them to learn to code, like to solve their own problem, because the software there is no software yet to develop this method, or maybe you can just uh, compare other method that already out there, something like that. And finally, it could be a developing tool if again you are good enough with Python and you have your passion here. You think that you are an advanced programmer in Python, so you can contribute to our community by creating your own geoscientific apps from the accessing libraries for fun, or maybe commercial purpose if you want. So yeah, it's very it's fair to say that everyone, like every geoscientist who want to learn Python, can write a code. It's just copy from the libraries, or maybe you write it by yourself to solve your own problem. So let's get started. In this talk, I will try to deliver several examples that I have ever done, or just trying playing around with the libraries. Like uh, the first example from my MSc, I'm doing query point depth mapping using aeromagnetic data for geothermal exploration. And the second example is playing around with the well log data. And the third example will be fault identification using seismic data. This will be an machine learning implementation too in this in our subject, if you are interested to the machine learning part. And finally, I will also show you several software that Python made that you can use to deal with your data set later at the end of the presentation. So let's start with the first example. In this case, I didn't use any machine learning technique. Actually, there was, but I didn't touch the machine learning part in this talk. So I used the library to process my aeromagnetic data. Then this is a real thing. I use the actual data set. I publish a scientific output, and Python give me a master degree. So if you ask me what Python is for me, like it's something for me. It's a really huge thing for me. So it was back in 2018 while I was working on my MSc titled Carry Point Mapping under Botswana for geothermal prospect identification using random data. Uh, CPD is the simple estimation of CPD is the depth where the magnetic property losing its ability at 551 degree Kelvin. So I need to apply this sophisticated formula to this data set to generate this chart. So the depth of CPD is just simply adding the age and age. Of course, there is a software that provided by my research group to do this calculation, but the problem is this this is only generate one single CPD. So from this map, I only have one. So the solution is, in order to generate the CPD map of entire Botswana, I need to subset the magnetic data and move the window constantly to entire map of Botswana. So instead of subsetting the map manually into 100 windows and perform CPD using the software, I asked Python to do this. There is a Python library called PyCurious that was built to perform this calculation in the manner that I want. This library subset the image, moving the subset window, and apply the calculation to the entire window, to the entire area automatically. And here is the code. The most important thing in this processing the data is you need to understand the form of the data. So here I load the data, I reset the data, I specify the window size, also the spacing. So then I plot the data here. This point is indicate the centroid of each window that calculated by this PyCurious, and I plot it in Matplotlib and do it simple interpolation, and here's the result. As you can see, I can find this shallow CPD here, which has indicate the good potential of geothermal area here. So from Python, I can process my data and produce a quite like, yeah, I think this is a good finding from my research. So it's commonly known that geophysical interpretation often casts a problem in Bayesian network framework while seeking the parameter using the probability term. So did this operation. This library, PyCurious, use a metropolis testing method, Markov chain Monte Carlo method to obtain the inversion parameter. But let's leave it like that. I will not discuss about it that further. So the point is, from this parameter tuning, the CPD map generated from the mean of delta z or h plus h, and the uncertainty is the standard deviation of the result. You see, there is a, yeah, it is just a result. So here's the code to generate the uncertainty. So from this aeromagnetic data, I perform this formula to get this power spectrum chart and create the CPD map and the Botswana plus the uncertainty with Python. Let's move on to the second example. This time I will playing around with the well log data. I will use a simple machine learning technique using sklearn library. This one is adapted from a journal draft I submitted earlier this year. If everything is going okay, this paper will be published next year. I hope. I will also add a simple non-machine learning process that we could also do to this data after physical calculation. So the problem is we have three well 1, 2, and 3, and one of them didn't have any NPy log. Let's imagine like that, because in real life the most common missing log is the DT, but in this case I will just predict the NPy log. So I load all the data using the Lazio and display them using Matplotlib. Then next, the next step is data preprocessing. As I mentioned earlier, this one is simple machine learning, so we need to do some pre-processing like data conditioning or like splitting the test and train, data standardization, or applying PCA. Everything for this data pre-processing or preconditioning is available in sklearn library. Then after applying this pre-processing, the next step is creating the model. In this case, I use Gaussian process regression, which is also available in sklearn. Actually, there are many other robust techniques such as random forest, neural network, etc., etc. But in this case, I will only use the simple one here. With this model, I was able to get the R square at 0.66 from the taste data. So from this scatter plot, we can compare the prediction with the actual data, and it's not that bad. And let's go with this model. After we have the best model, we implement the model to the well tree to get the NPy value. Since we have the actual value of the NPy, we can compare it, and the result is quite okay. In real life, we need to do some data like model validation and changing the parameter, or even maybe switching to the other method that I mentioned earlier. But this one I will use this log for the petrophysical calculation. So again, we load the data using Lazio and display it using Matplotlib for the well tree. We have the logs here using the NPy predicted NPy. So then we know the formula to calculate the fish shell, the porosity from density, water resistivity, and water saturation. In Python, we just need to write this down like this. We define the function, then we can just passing the argument here using our log later, like this. So we define this well, then we want to calculate the fish shell. We pass the argument gr here, gr here, gr here. Quantile is like the maximum and the minimum. And then yeah, for the rest of formula we can apply to our well. Like here we have the pi e calculation, visual, and water saturation. By calling this script, we can assess the result of our calculation here. So now we have plot of your calculated petrovisic log. But if you want to have a better visualization rather than this one, you can use bokeh or plotly and design your own template. Now you have a fancy visualization like the expensive software have. So it's up to you. You can design it by yourself. Let's move on to the third example. This one I process the SegWay data. I will show you a machine learning case on a seismic cube. In this case, I will do a fault identification on seismic data that using convolutional neural network. So if you want to do this to your seismic cube, you can use the training data in the model to your own seismic cube by visiting this GitHub. They already have the model, the training data. So if you just want to know how is the model and the train data works to your data set, you can just copy the code just like I did here. So first it's loading the library using segwayo, and I download the model here. So instead of creating a new model using the train data, I just use the model they have and see how good this model work in my cube. Like I mentioned earlier, this is the example of casual tool. I already have my cube, I already have the interpretation. I just want to know how Python or how machine learning can interpret a fault in my seismic cube. So I didn't do any improvisation. Just later I will show you what I did in fitting my data to this module. Then yeah, as I said earlier, just copy the function. This is we set the mask for the training data overlap, and here's I just apply the data. I just apply the model to my seismic here. I loaded my seismic here. I load using segwayo. We have the cube, and we reshape the seismic into the form that this model want to. Like we have a model, but they always have the requirement. You need to have the data like this. This one is this one is that. So I just reshape the data. This is the data, the GX, and this is a shape. So then I process the data using their code, and finally we save the fault interpretation to our disk, and then we can visualize it later like this. I visualize this using matplotlib again. We can see the left one here is the seismic line, and this is the fault interpretation. So see, the result is not that good, but if we overlay the data to our seismic like this, you can see there are several good results here, here, and here. But we need to also supervise the other. And here is what geoscientific need to do to this data. We supervise the machine learning part of the interpretation. So don't worry, we will not be replaced by the machine learning, but this machine learning will help us to make our life easier. So instead of uh, like uh, look at this seismic from scratch, we can see we have here, so we can interpret later in our software or maybe in Python. So it will help us, will not replace us, because we need to supervise this result in the end. Now I have a bonus. So we have able to visualize the last and the segway file nicely using Python. So we can. If you want to learn Django, you can display your data like this, and you can attach this to your data management system as a web app or maybe to the dashboard. I will try to share it later if we have still more time after the Q&A session. And the last part is build your own software. Again, if you think you are good enough in this programming language and willing to contribute more than just publishing some libraries on GitHub, you could build your own software. Here are several examples, like Mira Geoscience, Pgimli. There are many other software out there. I cannot mention it one by one. It is some of them I already working around with this, but I know this from a friend of mine. Also this one. If there is time left after the Q&A, I will give you a sneak peek to this mirror geoscience, and maybe a little bit from what me and my team did on the web app development, my company. I saw it earlier, this one. Maybe, let's see. To conclude, I have several points that I want to highlight. First, Python is not just a machine learning tool. It, as I demonstrated earlier, you can do almost anything you want with Python. Then, I believe that everyone can write Python codes, right? Like you want to calculate the better physics, write it by yourself instead of buying the expensive software. If you have, just use it. But if you are a student or maybe PhD, or maybe like me, I didn't work in the company, so I need to have a tool to calculate the Pareto physics to my dataset. So Python and machine learning will never replace us. I'm quoting a good statement from a friend of mine. Geoscientist's role is to supervise the result of the unsupervised method. So instead of worrying, why don't we start coding? Huh? So I think that's all from me. I will upload the PowerPoint and the Jupyter on my GitHub maybe in a week or a couple if you are interested. And let's move on to the Q&A session. Thank you and good afternoon, Mr.
All
Lutfi.
right, thank you, Mas Izzul. That was an amazing talk. That's pretty heavy material because this is really specific to geosciences. But I
Yeah,
believe we have
sorry.
a considerable masses of geoscience audience. So while we were waiting for the audience, probably still processing your presentation is because it's
Okay,
a
maybe I
pretty hard
can.
subject.
If you're not a
So you
geoscientist,
probably, yeah,
then
if you want to
yeah, yeah. Maybe I
let me
can show
show
you.
your
Yeah,
demo code, well, we can do it now.
yeah. This is the Myra Geoscientist product called GeoApps. You can do many operation using this. You can just download the module and you can install it. This is delivered in Jupyter platform. So like this, I mentioned earlier, you can detect the fault from magnetic data like this. You can call it. You can select your data. Sorry, you can select your data, which one that you want to use. Then we can work on Z like that. You can compute. Oh, sorry. Let's go with yeah. This is just. Oh, okay. Let me refresh it. I don't know if I don't know what. I think I did something wrong there. Let's just copy like this and have a new like this. See, you can change the parameter, like the threshold, like that, and you can choose other like we have inversion, we have scatter plot, we have they have many tools that you can use to your data, and it's this one is open source, so you don't need to pay for to do this to use this module on your data set. I think yeah, this one of the example that you can use with Python. If you are good enough in Python, you can create it by yourself because hyperspectral Python is a software that developed by my lecturer back in 2020. They use PyQt to uh, to create the user interface, and I found it quite good. So maybe you can just visit them if you like. If you are IP, oh no, IP Python Wimbaker. You can download it here and see the feature is quite good. You can deliver the data into NP format. So after if you don't have the NP, you can calculate it and give it to your friend who has NP to process later. But the software has very good feature like You can do PCA, any filtering, spectral angel mapper, and any other feature that you need to process in hyperspectral imagery. I think that's all. If we don't have any question, maybe I don't know.
Okay, we have one question actually for now, so I'll show it to you. So from your Yvonne Andrew, oh, he's also the speaker here. Do you have any good
Uh,
introductory book on geoscience topics?
uh, what you mean the implementation of Python or general geoscientist topic? Because if you want to learn geoscience topic, yes, you need to take uh, degree like geology, geophysics, geography, geomatic. That's what you need. But if you want to learn about the implementation Python in geoscience, I cannot remember the uh, name, but I found you can look at the LinkedIn. Sorry, they have there is a book from I don't know, maybe Middle East people.
Oh,
They
the question
publish.
follow up. Do you want to know specifically about the Python implementations, or we
Yeah,
can
yeah,
show them too?
yeah, yeah. So let's see if it come up in Python for geoscience machine learning. I hope we can find here. I don't know. Maybe I will share it to you later. Who, Mr. Yofonel? Maybe I can DM you later and I'll give you the link of the book in Hopin because I cannot find it right now. I'm sorry, but I can show you. I can show you. I will DM you the link of the book. Is there any other question?
Okay, yeah, there's several other questions. The next one, what are the most used case regression or classification and machine learning models in geospatial analysis?
Regression classification maybe for geospatial, like if you are working with the hyperspectral data, you want to classify the mineral mapping, you can also use the regression method. Or yeah, maybe the lithology classification from DM. You can also like working with the NDPA. You can delineate the boundary of tree or any specific lithology using the satellite images. That I think I've been working with those kind of stuff for geospatial analysis. Any
Okay,
other question?
next question. How did you get into geoscientists? This is the first time I've seen machine learning used for geoscientists, and that's so cool. Yeah, that's your
Uh,
answer.
Back in late 2000, oil and gas industry is very sexy. We paid well back in the day before the oil drop. So I took geology as my major in my bachelor and master. Then while doing my master degree, Mr. Becker told me if you want to do something more and without any tools, you can use this programming language because actually there is a course in my master called programming for data handling. We need to choose either we use IDL, Python, or R, I think. Then I decided to select Python, and it's helped me to get my degree. So that was a life changer for me. From that point to today, I keep playing around and trying to explore what Python can do for us as a geoscientist. And yeah, that's so cool. We know if you are geoscientist too, you know the software is quite expensive, like $5,000, or at least more than $1,000, more than $10,000, and you can do it by yourself for free using Python. That's cool, right?
Okay. Next question. Thanks for sharing, Izzul. I'm new to geoscience. Is libraries such as Valium useful for geoscience visualization? Furthermore, is there any relationship to this topic and BIM, right? Building information modeling, I guess. Yeah.
Uh, I don't know. I haven't tried the volume one, but maybe we can discuss later. Whoever this discussion come from, you can DM me on my LinkedIn or my email, and we can discuss later. Maybe we can share any kind what kind of library that you have been going through, and I can share mine too. So yeah, whoever come with this question, I never use this volume or the BM topic, BM related libraries, but I'm open to discussion. You can reach me out in LinkedIn or maybe GitHub or any other platform. Nice question.
Okay. Yeah. Next question. I bet we're all here mostly not have geoscience background. With this machine learning stuff, should we already have this basic knowledge about geoscience?
If you want to make money from geoscientific subject, you should. I told you, so you should. I have a friend of mine now working on creating a new software for geoscientific problem. Now, so instead of buying the expensive one from out there, he has the vision like, instead of buying from the outsider, let me uh, create a new software and you buy it from me. So if you want to make money from there, from that kind of stuff, so just maybe you should try to learn just a basic knowledge about the science so you can reach out that opportunity.
Okay. Wait, there's a. Okay, can HiPy also be used for multispectral satellite image analysis, or it requires the multispectral image as the input data?
So I get a geoscience scientist here. If you are interested about this hype stuff, yes, this hype can do this. You can visit my lectures website called frankstutorials.nl, and you can see there from several examples and the hyperspectral data set from satellite or from the camera. So you can play around with those kind of data set with this hype. Just go through the website. This is a cool website. I know you are just like this here. Yeah, it can process the multispectral data too as well. I think, yeah,
Okay.
I think it could.
Anything more to add, maybe? Wait, he actually has some.
Geoscientists
Wait.
around. It's nice to see that I can find some geoscientists uh, in this room, because I'm afraid that nobody will come to my room, because last year maybe I only see three other geoscientists in PyCon 2019. Me, my cousin, and my friend. This year we have, yeah, good. I'm happy with this.
Mhm. Yeah, he
Any
said
other
he's
question?
the geomatics engineer. So yeah,
Uh-huh.
his background is
Yeah, yeah,
also in
yeah,
geophysics.
yeah. That's good. We can discuss maybe. You can reach me out in
Okay, we
LinkedIn
probably
and we
have.
can discuss further.
Yeah, you probably have like a page where you put your social media, Twitter, LinkedIn, anything.
Yeah, I
You can put it here so
think
the audience can contact you.
here you can visit my GitHub at Panjul4, or you type like LinkedIn Izzul Qudsi. That's, I think I'm the top one because it's not a common name in Indonesia actually. So you can reach me
Yeah,
out on
all the social
Instagram.
media with this username, right? Okay.
Yeah, it's Panjul 4.
Mm-hmm. Okay. Okay, last chance for some last few questions, maybe. We're still waiting here. We have like probably 10 minutes tops, but 5 minutes
I
will be okay
think,
for now.
yeah, I think
Wait,
this is
no, we
a
have
good discussion.
one question.
By the way, I will share this presentation and Jupyter in my GitHub later, maybe next week or a couple weeks from now, because I need to remove the data, like the data. But yeah, just try to maybe follow me first.
Okay. Next question. How about
Kemarin
classification of
minus.
remote sensing imagery in deep learning? Is their methods good enough compared to time and scale of our computer?
Uh, Actually, what kind of deep learning? Because if just a machine learning like simple processing, my colleagues in back in my MSc did this kind of stuff a lot, like edge detection. Maybe you want to map a shape of the uh, mineral from a core data that been captured by the hyperspectral imagery. And again, back to the what kind of deep learning that you want to apply. If this and also don't forget, remember, we the geoscientists need to supervise whatever the result from this machine learning of deep learning stuff. So is it good enough? Back to you as a geoscientist. Are you happy with your model with the deep learning or machine learning? So I cannot answer it. It's back to you. Are you happy with that model? And how good are you in playing around with the parameters? Because yeah, it's mostly it's about the data quality and the parameters tuning. If you talk about this kind of stuff. So I cannot answer. Is the parameter good enough? It's back to you. Are you happy with your result or not? So maybe that's my answer for this one. But classification in remote sensing imagery is often sit in our if you are if you are geological remote sensing student or maybe professional, you know it already we already done this a lot.
Okay. Last chance for last question, maybe. So I'll count to 10. So we have last few seconds before we close this session. That was an
Okay.
amazing talk. Lots
Yeah.
of insightful
Yeah. Do
uh,
not. One
content.
last message. Do not hesitate to contact me by LinkedIn or any other social media because
Oh,
I'm open to
yeah,
any kind of discussion.
I'll show it to you. This one, right? The username is
Yeah.
outsame
Yeah.
4.
Yeah. Thank you very much, Mr. Lutfi. Thank you very much. It was a
Thank you,
nice
thank you. Okay.
talk.
Thank you, thank you. That was a great
Uh,
session. It was
Opportunity.
happy but so insightful. Unfortunately, we ran out of time. So, do you have any last remark for the audience, maybe?
Uh, Again, the statement from my friend, geoscientist role is to supervise the unsupervised method. So instead of worrying, why don't we start coding?
Okay, that is insanely insightful. Thank you so much very much for that, Izzul,
Thank
and
you,
also
Mr. Lutfi. Thank you, everyone.
thank you.
Thank you for
So,
having
I
me.
love
Bye.
you for the session and see you soon in next session.
Bye.